So we're going to look at example 1. The table below gives the time in minutes versus the height in meters of a Ferris wheel. The diameter of the wheel is 76 meters. So we have time t in minutes and height h in meters. So I'm going to get you to pause the video at this point and enter the data in to the lists and perform your sign regression. I've got my data in, and I'm going to do, I've done the sign regression and it's here. So hopefully you've paused the video and you've gotten your data up. So now I'm going to just record my equation. I have y is equal to 38 times the sine of b 0.698 x minus 1.57 plus 46. Okay, so enter the data above, perform a sign regression, round the parameters to the nearest hundredth. So I could do this one to 70 to the nearest hundredth and set appropriate windows for the data. So here's my window settings. I have 0 to 20, scale of 1. For the y, I have a 0 to 100 with a scale of 5. And you want to set those windows and graph the data on the calculator and the equation, and then you would sketch the graph you produced. So you would just produce a graph that looks something like this. And as I say, I chose to go out to 100. That goes beyond the, sorry, not out to 100, out to 20. That goes beyond the data itself. And so there is, no, that didn't pull off quite the same way. Is it dropping? Let's see, is it dropping down further? Interesting. Okay, well, file, take a screenshot. No, and I can't. Sorry, I should have played with this sooner. I apologize. Won't waste any more time. So if you do a sketch, you would do your x and your y axes. This is time in minutes. This is height in meters, and I've gone up to a maximum of 100, and my minutes I've gone to 20, and we're down here with a low at 8 meters. We go up, come down, go up, come down. So that's the kind of sketch we're looking for. We're asked to determine the period of the graph and describe what it represents in this scenario. So to get the period, we use our b value. So the period is equal to 2 pi divided by 0.70. That's our b value. Let's calculate that. So 2 times pi divided by b, which is 0.7, and we get 8.975. This is going to round to approximately 9 minutes. And it asks us to describe what it represents. And what it says is that the Ferris wheel takes 9 minutes to make one complete revolution. And now let's go to question B. What is the relationship between the amplitude and the diameter of the Ferris wheel? So in our equation, I'll just scroll back up. Our equation, we have an amplitude of 38. So our amplitude is 38, And remember that the height is measured in meters, so that's an amplitude of 38 meters. And the diameter of the Ferris wheel was 76 meters. And so we can see that the amplitude is exactly half the diameter, and so the amplitude is the radius of the Ferris wheel. Number D, how high above the ground did the people, I think that should say aboard, or the Ferris wheel, on the Ferris wheel go in this scenario. So let's go up. I'm going to show you an example. Now we could calculate this by hand, but I'm going to go to the graph, and we can see that our maximum is, our data point is there. So we're looking at 84 probably is our maximum. But we can also get our calculator to do that, find that for us. We go second and trace, and we want to find maximum, number 4. And so we put our cursor on this, where it is, it's on the left side, press enter. We need to move it to the right side, and we go up and over, and it doesn't matter which maximum we choose because they're identical. And then it asks us to make a guess. We bring our cursor back up to the top, we press enter, and we get a value of 84. So the maximum height is 84 meters. And why am I stuck? Okay, I got that to move for us. And so we can say the maximum height, or yeah. How far above the ground would a person be after 3 minutes? And so we can again use our calculator to calculate that for us. We go to second and trace, number 1 for calculate, press enter. We're going to enter 3 for 3 minutes, that's our X value, and then the calculator comes out and they would be at 65 meters. And that's probably very hard to see, but it's 65 meters. So the person would be 65 meters above the ground after 3 minutes. At what point or points is a person 15 minutes above the ground in one full revolution? So now we're being given a y value instead of an x. So to calculate the y value, we can enter in y2 that value, the y value of 15, and we graph it, and we can see that red line. And one complete revolution ends here. So we have 2 times when the person would be at 15 meters above the ground. So we take, and this time we're going to calculate our intersection. So that's second, trace, and 5. And we're asking it for, it asks us if this is the right equation, and we say yes, and we say yes again, and we move our cursor to that intersection point and calculate the value, and it's at 8.11 seconds or 8.12 seconds, so that's one of our times. And our other time is earlier, so let's do that calculation again. Second, trace, and we're going to go to number 5, intersection point, move our cursor over towards that other intersection point. So we're sitting there. Again, we say first curve, second curve. So yes, and now calculate. And it calculates after 0.883. So 0.883 seconds. Now, sometimes we need to take those, or minutes. Those are both minutes, I apologize. And we don't think in that 0.8 of a minute. What we do is we take and calculate that into seconds. So let's get out of here, and I take 0.833 and I multiply that by 60 seconds per minute. And so I'm at 50 minutes approximately. Sorry, 50 seconds. So we've calculated, we've taken that 0.88 of it. Sorry, it's 0.88. Gee. Times 60. I'm just trying to rush here, and I apologize. So that's 53 minutes approximately. So seconds. So let's take this decimal stuff out. So we're going to put in at 53 seconds and at 8 minutes, and we have the 0.12, so we do the same thing, 8.12, so 8 minutes and 0.12 parts of a minute. Turn that into seconds by multiplying by 60. So at 8 minutes, 7 seconds. Okay, how long to the nearest tenth of a minute is a person in one complete revolution when he's at least 15 meters above the ground? So they're in to the nearest tenth of a minute. Well, that would be 0.8 minutes into the revolution and 8.1 minutes. Oh, how long? Oh, sorry. I get it now. My brain went blank. So I'll go back to the graph. So from this intersection point to this intersection point, it goes across, and in that time, they are at least 18 minutes above, or 15 meters above the ground. So how long are they? For what portion of the revolution? So let's scratch this out. And so I can take the 8.12 and subtract from that the 0.88, and that difference gives me how long they are above 15 meters above the ground, how long, for what period of time they are for 15 meters above the ground. So let's go back now and we'll calculate that. 8.12 minus 0.88, and that gives us, so for 7.2 minutes. So H asks us to write the equation of the median line or the midline. That's y is equal to 46, and if we look up here, it's plus 46, and they ask us to put it on our graph, and so we can draw y is equal to 46 meters on our graph. So now let's scroll down and we'll look at number I. A new Ferris wheel is constructed that is 1 meter higher when boarding than the original wheel. Describe the effect of the new height of the wheel would have on the amplitude on all of these things. So if we think about it, there's a new Ferris wheel. The only difference is it's a meter higher. If I look at my graph, let's go to the graph. If it's a meter higher, all I have is shifting the whole thing up by 1 meter. So the amplitude isn't going to change. It's going to stay the same. So no change. The period of the graph, no change, because it's the same size, it's the same speed, it's just at a higher height. So no change. Now, the median is going to change. It's going to increase by 1 because the middle of it is now 1 meter higher. So it will change by an increase by 1 meter. And the height of the graph will also increase by 1 meter because everything is higher. And it's asking us to describe a method to determine the new function of the graph for the wheel. Well, essentially, nothing is changing but the median. So we have y is equal to 8 times the sine of, and what did we get for that value? 0.7 minus 1.56 and plus 7. So 0.70 x minus 1.57 plus 447. The only thing that's increased or changed is the height. Okay. And now we're going to determine the maximum height of the wheel reaches, and that's, we take 8 plus our median, our median, not plus 8. And I don't know why I'm stuck at 8. 8 is from our last piece. It's 38. There we go, much better. So it's 38 plus our median, which gives us our maximum height of 85 meters. And one of the methods that could have been followed, other than this, is to look at the data that we had and simply add 1 meter. So create a new table of values with 9, 47, 85, right? Everything's just going up by 1 meter, and redo the regression. But in this case, really everything's the same. It's shifting up once. The piece that shifts it up is the median line. I'm going to stop this example, or stop the recording, and there will be another recording for example number 2.